So we are on exact ODE. They are of this form: P xy dx plus q xy dy is equal to 0, where P and Q are functions of x and y. So when you see the brackets, it means that P is a function, it has a function of x and a function of y, or it can still have one or the other, but it's still a function of x and y. So that is basically exact ODE. They are of that form. So before I begin, maybe we do some recall. We do some recall on partial derivatives. We start on partial derivatives, and then we can be able to proceed. Let's do a recall here. So partial derivatives. We are given that z is equals to xy plus x squared plus y squared. You can be able to get what? You can be able to get zx. Zx. Can someone try zx? So last time we had said zx, we shall be differentiating in terms of what? In terms of x, assuming that y is a constant. So like this one here, when you differentiate now in terms of x, we are considering that y is a constant. So y will remain. Differentiate x squared, you get 2x. Now here there is no function of, in this function of y squared, there is no function of what? Of x. So to differentiate, you just get a 0. So here the answer will be y plus 2x. Why? Because we considered in the first one, we considered x to be a constant. Sorry, y to be a constant. We can still be able to do this. Zy. We differentiate in terms of y, we shall assume that x is a constant. We shall remain with y. No, we shall remain with x because we are differentiating in terms of, we shall remain with x here. Because when you differentiate y, you get number 1. You get number 1. So we shall be able to get x. Differentiate x squared, there's no y, so you'll get 0. And then differentiate y squared, you get what? 2y. So you're getting here x plus 2y. X plus 2y. The final answer for that one. So I'll do another one. Zx. Z is equals to 2x squared y plus 3xy squared. So again, zx, if I differentiate in terms of x, I'll assume that y is a constant. I'll assume that y is a constant, and cannot be able to see anybody. They're struggling to hear me. Okay, let me use an exact differential equation is of that form: P xy dx plus q xy dy is equals to 0, where P and Q are functions of x and y, or they can be just be functions of y of 1. Then I went to the partial derivatives that we did in calculus. That is z. If I give you z is equals to that, and I tell you to differentiate in terms of what? In terms of x. Basically, zx, we are differentiating in terms of x, assuming that y is a constant. So in the first function, we have an x. So you just differentiate the x, you get number 1. Here, there's a number 1 there. Then the y remains a constant. Then differentiate x squared, you get 2x. Then y squared, there's no x, you get 0. So you remain with y plus 2x. On the zy, when you differentiate y, you'll get here, there's a 1 here. And then 0, on the side of x squared, and then y squared, we get 2y. So we get x plus 2y. So what we are doing partially is that we are differentiating in terms of one function. We are assuming the other function to be a constant. So I was at number 2. I was at number 2. I think Florence, if you say katika, I think it depends with your network, because the other people are saying it is okay. It depends with your network. So zx, this one here, differentiate in terms of x, you shall get 4. You shall get 4 xy. The power will come down plus 3. There's 1x there, so you remain with y squared. Then zy, when you do this one, in terms of y, you'll get 2x squared plus, that is 6xy. Differentiate one, leave the other one. Now it is still impossible. It is still possible to do partial integration. Partial integration. You can still be able to do partial integration. So you can be able to integrate partially this one. If you have a function, let's say xy plus, let's say x plus y, we integrate this one in terms of dx. It means I'm integrating in terms of dx. That one is called differentiating, and the same procedure will be there. We shall, when integrating in terms of x, we shall assume that what? That y is a constant. So this one we shall assume y is a constant. Is a constant. That's how we assume. So when integrate that one, we shall be able to get now. So when you integrate this one, we shall get so our main concern is this, the x. Our main concern is where you have an x. So we are assuming that y is a constant. So the first one, we shall have x squared. We'll have x squared all over 2. We have integrated that one. Y is a constant plus x squared all over 2. And then again, we have here y. So so if y is a constant, when you integrate like 2, when you integrate like 2 dx, you always get what? 2x. When you integrate that one, when you integrate 2 dx, you get 2x. So integrate dx, you should be able to get what? X, y, and then plus a constant of integration. You can be able to see, I'm just integrating only the x. I've integrated again the x. Now the y now, because you're assuming that y is a constant, when you integrate the x, you'll only end up with what? You'll only end up with x. And I guarantee when you differentiate this one partially, you should be able to get what we have up there. You shall be able to get the same thing. The same thing. I can't see the board.
Mwalimu, still I'm having some issues with the sound. I'm not.
But I think Masinda, it is your net. It is even me. I cannot be able to get you clearly. Okay, let's do this because the interruption had Nini and made me have to repeat again that one. So we are on number 2. We are integrating in terms of y, x squared plus y squared plus xy dy. And we had said we shall be able to assume as x as a constant, where you have x squared it is a constant, so you'll end up just with the y. Then the normal way you integrate using power rule, you'll have y to power 3 over 3, and then you'll have y squared over 2. And we have said that you can be able to see that the x is not affected in any way. The only function that is being affected is the y. Why? Because of here. Look at this one, the one that I'm marking in red, this one. Because we are integrating in terms of y. That is what it's telling us. We're integrating in terms of y. Now with that, I believe we can be able now to go now to exact differential equations. We do 3 examples that are there, and then you'll be able to tell me. So let's go now to exact now. So we said an exact differential equation that is of this form. Sorry, dx is of that form. So how do you know? How do you know that this equation is exact? How do you know this equation is exact? You can only be able to know if it is exact if and only if dp, we differentiate that function in terms of what? In terms of x, or in terms of y, will be the same as dq all over d1 dx. So before you begin to solve an exact differential equation, you must be able first of all to check that this condition is satisfied. That you can be able to see the p that has the x, we differentiate first of all in terms of what? Dy. Please don't confuse. This one is in terms of dy, this one is in terms of dx. Please don't confuse. I know here I have a dx here. I'm able to see the dx and the dy. But we differentiate p always in terms of y and the q in terms of x, as if we are interchanging the two. As if we are interchanging the two. So that's how you check if it is exact. If this condition is not satisfied, then it is not exact and you cannot be able to solve it. Either you can be able to solve it by separation of variables, which I'll come later on to the integrating factor. But for now, this is how you check. Let's do the first example. An example will be able to demonstrate all these for you. So we shall check first of all if it is exact, and then we proceed to solving. An example that I've given you, this one here, 2xy dx plus x squared plus 3y squared dy is equals to 0. So before you begin, I'll go back to the odds to check if it is exact. So this one is my p, and this one is my what? My q. Why? Because we said the q goes with the dy, and the p goes with the dx. So I need now to differentiate this one partially. I differentiate partially. So we have said that p is equals to 2xy, and then our q is equals to x squared plus 3y squared. So I'll differentiate p in terms of y and q in terms of x. If they are the same, then we shall be able to say it is an exact differential equation. If they are not the same, it is not an exact differential equation. So let's do this one partially. So I have partial p, partial x. Sorry, partial p, I'm even confusing. Partial p, partial y. That's what I had said. Partial p, partial y, partial y, partial y. And this one I'll do partial q, partial x. I've given you a recall. So when you're differentiating in terms of y, we shall assume x is a constant. So this one shall only get 2x. The other one, when you're differentiating this one in terms of x, we shall assume that y is a constant. So we shall be able to get 2x. Then we have y 0. So the answer will be what? 2x. Which means that what? Partial p and partial y is equals to partial q, partial x. So our equation is what? Exact. So that's the first thing you check. You check if the equation is exact. Don't be in a hurry. By differentiating p partially in terms of y, and we differentiate q partially in terms of x. So now if they are exact, then it becomes a bit easier. Now from there, this is what we do now. And I'll go back to my p. So my p was given by 2xy, and my q was given by
Can you repeat on how to know that it is exact?
how to
How to know that the equation is exact? I have lost on the way somewhere there.
how
Or
to
can
know
you
the
just
exhibit,
repeat the whole question?
how to know the equation is exact. You have said now where you have the x, the function that is before that, the function that is before that becomes my p. First of all, are you okay with that? This one is my p, this one is my q, according to this equation. Okay, let me first of all remove the recording. We are okay. So I was back and I was saying that now we need now to be able to solve that equation. I've repeated back my p and my q. So the first thing that I'll need to do is to introduce two variables. The p, this p, I'll call this one partial u, partial x. I'll call this one as my p, and then partial u, partial y, I'll call this one as my q. So these two variables will be able to assist me to be able to come and solve that equation. So if you go back to the notes, I'm using partial u, I'll call it p, and then partial u, partial y, I'll call it what? I'll call it y. I'll call it y, so that I can be able now to be able to solve it now. For me to be able to solve it, that's how I'll be able to do it. Now, so I'll proceed and do that. So it means that partial u, partial x will be given by 2xy. Then partial u, partial y will be given by x squared plus 3y squared. So here, I love using this one. So using this one now, I'll solve for you. So for you when you do what? When you pardon? When I integrate. I can only be able to solve for you if I can only be able to integrate. I can only be able to integrate. So this one I have here, I can be able to arrange this one, check now this one out, check this one out. This one now can be given as partial u is equals to 2xy partial x. I'm able to see I've cross multiplied. I've cross multiplied. Upon integration, so I'll be integrating partially. So when I integrate, I'll get here u will be given by the integration 2xy. I'm in terms of x and constant. It's 2 the way it is. Plus a constant of integration. A constant of integration 5, that's what I've used in my notes. A function of what? A function of y. So the constant of integration, we call it phi a function of y. So this one will remain with what? X squared y plus phi y. So phi y is a constant. Instead of introducing the normal constant of integration, this one here, I'll call it is a what? Constant of integration. Because I'm integrating partially, it shall be a function of y, constant of integration. So remember that one will always be a function of y. Why is it a function of y but not a function of x? Is because when I differentiate a function of y in terms of x, I should still be able to get it 0. Yes, because y is a constant. That's why we are calling it a function of y. So I'll repeat again. I have partial u is equals to 2xy. I need u. So I've done what? I have integrated in terms of x, assuming that y is a constant. And the constant of integration, I'm calling it phi y. I'm calling it phi y. You can still be able to follow up. I will upload the video. I'll make sure I'll upload this video. You can easily be able to follow up. So I was saying that we have integrated in terms of what? In terms of x, we have gotten that, but the constant of integration, we are calling it phi y. It just phi. Most books use phi. You can even still use cy. It's no problem. But in my notes, I want to be consistent. I've used the phi y. So that is the constant of integration. So I've gotten the value of u. This is my u, my u. Now after getting my u, remember I've integrated the partial u by integrating x squared y plus 5. So after I've integrated now, because I wanted this, I wanted now I'll again differentiate in create a partially check one that mark in the function differentiate function only once. Only once. So when you differentiate phi,
Excuse me, sir.
yes.
Sasa una katika hata tukusikia wallahi.
And now can you do better? So I use the first equation to integrate to get u. And after getting u, I differentiated in terms of y so that at least I can be able to compare with this equation in purple. That was my main task. That was my main task. The first equation you integrate, then you differentiate to get in terms of y to get an equation similar to this one so that I can be able to compare the two. So I have the equation that I've differentiated down there that has phi. I'll compare with this equation, and then I am done. And then I solve for the value of phi. So can you note that equation in purple? It is given by what? Note it. So I'll go down. I compare quickly. I compare that equation and see what I'm getting. So this equation that I have, and the equation that is up there is this one. The equation that is up there is this one. That is up there is this one. The equation that is up there that was given by Q y squared. This is the equation number one that is up there. So I need to compare these two, and I'm done. So that's the differentiating, so that I can be able to compare now the two equations. Because all of them are on the left hand side, they have partial u, partial y. It means that these two equations must be they must be similar. So I can easily be able to come and say now here, I'll be able to come and say that x squared plus 5 prime y must be equal to what? X squared plus 3y squared. It must be similar. Now with this one now I can be able now to solve now for 5 prime. So 5 prime y so the x this x in terms of y, because y is a function of y. Remember?
We have
Yes,
lost your board.
yes. I'm resharing it again. I don't know what is happening today. Okay. I think the board is okay now.
Yes.
The board is okay right now. So, remember now our phi is a function of y. That's why I was indicating it is a function of y. So what you need to do now, after comparing the equation that I was telling you, number one, and what we have been able to do, you can be able now to solve for phi y. The x squared will come this other side, it will reduce to 0. So what you just need now to be able now is to integrate now in terms of y. So at least you can be able to get, you can be able to get the what, you can be able to get now the phi. So when you integrate this one, don't worry, I'll do another example. You'll get 3y squared, sorry, to power 3, all over 3. This one you shall be able to get it as what? This one, y to power 3 after integration. Add 1 to the power and you divide by the new power. So I'll go back to the equation that had the y. Check this one out again. I'll have to go up. But I think when you're doing it, it will be easier for you because you'll just do it on a piece of paper. Now this is the function now. The u. Remember the u that we had integrated. So this is the one that I'll be able to use because I just want to solve this one. The one in purple there. The problem with this one, it is not yet solved because it has phi y. And my main task was to solve for phi y. That's what I've been able to do in all going downwards. So what I need just to come and do is substitute the value of phi y in this equation and I'm done. So this one means what now? That u now, u will be given by x squared y. And then I replace the phi with what I have. So remember that our u, this is the first example, so just you can easily bear. So u was given by, I think it was given, u was given by x y plus phi y. So I just need to replace the value of phi y, which is y to power 3. So it means that u will be given by x squared y plus y to power 3. And then you can able to have not the constant c to be on this side. Now the constant c can be this side. And I'm done with that one. I've been able to solve. So the partial u, partial x, you do what? You integrate, you get u. And then again the u, you differentiate in terms of y. Then you use the other equation to compare. And then you can be able to solve for the value of phi y. When you solve for the value of phi y, you just replace where there's a what? There's a u. So let me do another example. Let me just do another example. Number 2. This equation here, 2xy not do this one first. Do a simple one. Three y squared minus 2x dx plus 6xy plus 2y dy is equals to 0. So the first thing I'll do is to check if the equation is exact. The equation is exact. So this one is my p, this one is my q. So I'll differentiate p in terms of what? Y. So this one partial p, partial y. If you do this one in terms of y, you'll get what? 6y. And then minus, there's no y, so you'll get 0. So that one is the same as 6y. Now the other one, the q, I will differentiate it in terms of what? In terms of x. I'm able to see, so maybe I go up. So I have 6xy. So when you differentiate in terms of x, I'll assume that what? That y is a constant. So y is a constant. So I remain there with 6. You differentiate the x which is coming to 1, the y is a constant, and then plus 0. So again you remain with 6y. So that equation is what? Is exact. Because these two, they are similar. If they are not similar, then it is not exact. If they are not similar, then it is not exact. Now, after doing that, now the checking if it is exact now, I can easily be able now to call my p. The p that I have, I'll call the p the partial x, and then I'll call the other one partial what? Partial u, partial y. So I'll have those two equations, and then I'll deal with one first until I get what I want. So I'll call partial u, partial x, my p there. I know you cannot be able to see it, but it was given by this one. My p was given by 3y squared minus 2x. And then my partial u, partial y, the q was given by 6xy plus 2y. So I'll deal with the first equation. I will integrate it, and then I differentiate it, and then I'll come later to compare with this other equation. So this other equation, I'll hold it for now. Basically, it is used to get the value. This equation here, the one that I'm circling in what? In red. This one. This one basically it is used to solve for the value of phi. So I'll leave it pending. So my main task is to use the first one. I can still be able to use the second one, but let me just stick to be using the first one. So this one means what? That partial u, the same as 3y squared minus 2x. All of this one is under dx. I've cross multiplied. Sorry, partial. This one is partial x. So what I need to do now is to integrate both sides. On integrate u, du, I'll get u. Now, I'm integrating that one in terms of x, assuming that we shall assume that y is a constant. We shall be able to assume that y is a constant. In terms of x, we assume that y is a constant. So in the first function, there is no x, so it shall just remain with 3 y squared x. The second one is an x, so I'll get 2x squared all over 2. And this one will be given by what? This one. Oh, sorry, plus 5, sorry, plus 5y. We said our constant, we shall always call it phi y, always phi y. If I simplify this one now, I'll be able to end up with what? 3y squared x minus x squared plus phi y. Always your constant there, but just call it phi y. After doing that, remember my goal is to solve for phi y. So I need to now to differentiate this one partially in terms of y now. I differentiate now this one partially in terms of y. I see what I'm getting. So in terms of y, partial u, partial y. And then I'll compare with the other function. I'm doing that one to compare with the other one. So partial u, partial y, what I'll need to do is to differentiate now in terms of y, assuming that x is a constant. This one will get 6 yx minus, there's no y here, so this one will be 0. And then we said for the phi, when you differentiate, you get phi prime y. You get phi prime y. You get phi prime y. This one I'm remaining with what? 6yx plus phi prime y. Now, I have what I need now. I'll go back to the other equation. So this other equation will be able to assist me because it will be similar to this one. I'll just compare. Check this equation now out. So I've used one. I need now to use the other one. No, the equation that I've circled here in red, this one. Again, I can be able to mark with another color, yellow. Now this one, I just compare this one with whatever now I've been able to calculate. And then I solve for phi y. And I'm done. So let me write it down here. Compare it. So the equation that is in yellow there is given by this one. The equation in yellow is given by partial u, partial y, by 6 plus
Sorry, sir, I have lost you.
side here, whatever I've circled there, equate the two equations. So equate the two equations quickly. Says they are so what I will end up here with is phi y. What I'm ending up with is phi prime y is equals to 2y. Now, if I want phi now, remember I want phi. I was doing this to get the value of the constant of integration. If I need phi y, we said need to integrate this one in terms of what? In terms of y, because phi y is in terms of partially in terms of what? In terms of y. That's what we need to do. We integrate this one in terms of y. So we integrate this one, the power rule will work. 2y 1 plus 1 all over 1 plus 1. Then we'll end up with what? This one. That is y squared. We'll end up with y squared. Now, you remember the function that we had called u? It is here. The function that we had called u. I'll just replace the constant of integration and I'm done. It is here. The function that I'd call u, it is here. This one here is the one that I'll just, this one here. U is equals to 3y squared. Is the one that I'll just replace the value of phi y and I'm done. And I'm done with that one. So kindly master that one, 3y squared, 3yx squared minus x squared. And just replace the value of phi. So u so u was given by 3x squared y minus x squared plus 5y. So what I just need to come and replace now the value of phi. So 3x squared y minus x squared plus y squared. And I introduce now a constant now basically because the equation can be able to hold up for anything. And I'm done with that one. So my main task was just to replace the constant. The constant of what? Integration, and then I'm done. So I'll do the final example, number 3. I do the final example. You can be able to go through the example that I've done and you'll be able to tell me. So this is the example that you have. Number 3, 2xy minus sin x dx plus x squared minus cos y y is equals to 0. So the first thing we shall be able to do is to check if it is exact. So this one p one measure the term x and then partial p. Remember sin x is when you differentiate in terms sin x will get 0. Sorry, partial q all over partial x. Again you'll get 2x. When you differentiate cos y you'll get 0. So again they are matching up. So this one is an exact differential equation. Because after differentiation, remember when you differentiate sin x in terms of y, you get 0. Cos y in terms of x, you get 0 because there's no x now. So now I can be able now to go and call now my what? My p. So partial u all over partial x will be given by what? Will be given by 2xy minus sin x. Then partial u all over partial y. My q
Sorry, I've
was
lost your
x.
board.
You have lost me.
Yes, your board.
The board again. Now partial u partial x to be my p, and the other one to be my what? To be my q to be partial u partial y. And you can be able to see that's what I was writing before the board went out. So this one it was given by cos what? Cos y. So this equation here that I'm circling, I will hold on to it now to compare. So it will be able to assist me to look for the value of what? Phi y. So the equation that I'm concerned with is this one here now. When you cross multiply, you'll get partial u will be given by 2xy minus sin x. This one partial x. We integrate this side and integrate that side. So when you integrate partial u, just like du, you'll get what u. This one will get u. Integrating in terms of x, so 2. We have an x there, x squared all over 2, and then the y will remain the way it is. So I've only integrated only the what, the x. Then we have another function. When you integrate sin x, what do you get? Someone who remembers sin x? Okay, sin x. Anyone who remembers from the table? Yes?
Cos x. Cos
You get
x.
what?
Negative
Positive or
cosine.
negative? You're getting negative cos?
Negative cos x.
Okay, so plus a constant of integration that we are calling pi y. Let's simplify this one and see what you are getting. So the 2 and the 2 can be able to cancel, so I will remain with the x squared y plus cos x and then plus pi y. Now what do we need to do from there? Well, the only thing that we cannot be able to do from there is to be able now to do what? To differentiate now. Because I want to compare the two. So I just differentiate this one partially in terms of y. This one is my u. So I'll differentiate this one partially in terms of y. What will I get here? So x is a constant, so I remain with x squared. I'm differentiating because x there's no y, so I'll get 0. Then I'll get 5 prime y. You're able to see the same tricks. We are getting every time 5 prime y, 5 prime y when you differentiate. You can easily be able to know when you're going wrong. So this one I'm ending up with x squared plus 5 prime y. Now after doing that now, you remember the equation that I had left? I'll compare with this one. So I go up again, the one that we had called q. The equation that we had called q. The equation that we had called q. The one I was saying you hold, this one that I have circled here, the one in purple here. I told you you hold on to it, that the q. This one equation. So I'll repeat it again down there, and then I compare with what I've gotten.
Excuse me, sir.
This one here. Yes. Yes, you are excused.
Mwalimu, hiyo hebu rudi hapo nyuma kidogo. Before now, hapo
the one that I had said you hold on to it will be able to assist us with something. So let me go up. This here. The one that I've marked in what? In purple. That equation there. Memorize it. Okay, when you have a big paper, you don't need to memorize it. So that equation, I write it down here. I write it down here, that equation. The equation in purple, it is given by this one. X squared minus cos y. Now you can be able to see all of them are partial u, partial y. So these two must be they must be equal. All of them are partial u, partial y, partial u, partial y. So I will equate the two. So it means that x squared plus 5 prime of y must be the same as x squared minus cos y. These two here, the x squared can easily cancel. When one goes to the other side, it can easily cancel. That one, we can easily be able to cancel because they are identical. So check this one out. That one and that one, they can easily reduce to 0. So I'll end up with what now? I'll end up with 5 prime y is equals to cos y. But you remember, I don't want 5 prime. I want 5. I just want 5. So to get phi y, I'll integrate this function in terms of what? In terms of y. When you integrate cos y, what do you get? Cos?
X sin x.
No, not
Sin
sin x.
x.
No. Someone else to try?
Sin
Not
y.
sin
Sin
x.
y.
sin
Sin y.
y.
Yes, sin y. Wait. Correct. Sin y. So I'll go back to the u. The u that we had gotten and replace back the value of phi. The u that I my board, you'll be able to confirm later. The u that we had, our u was given by this one. Our u was given by this one.
Excuse me,
Given
sir.
by x squared. Yes.
Why are we omitting negative cos y? That negative sign. Is it necessary? Are we omitting?
Give me a moment, I'll answer you. Where are you omitting negative sign?
Negative cos y.
Was it a negative? Let me check.
Yes.
Oh, sorry. Yeah, there's a negative. Sorry. There's a negative. Sorry. Yeah, thank you for that. So we're integrating negative that. So we should be able to get negative sign. Thank you for that. We should be able to get negative sign y. Thank you for that. So it's negative cos x. When we integrate cos y, we are getting sin y, but there's a negative there. Thank you for that. We had almost forgotten now. So I'll go back to the u and replace back this one now. X squared y plus cos x minus sin y is equals to now c, and I'm done with that one. So I've been able to solve it. I've been able to solve it for that one. I've been able to solve for that one. So I think the procedure for all exact equations is the same. Check if they are exact, then call one function p partial u partial x, call q partial u partial y. Then this partial u partial x you integrate, then you differentiate, and then you can be able to solve for the value of phi y, then you are done. The procedure you can be able to see is the same, and you can be able to go through at least the exercise that I gave you. You can still be able to go through the notes and we will be able to tell me. So the recording 51 minutes. After the